In this video, we're going to talk about how to take all of these different representations of linear relationships and put them in their different forms. The big thing that I want to stress is that no matter what form you have, your table right here is central to everything. You always want to get to this table right here, no matter what representation you have. So what we're going to do is take these ordered pairs that we have over here and plot them on our table. So what you want to look for when you're looking at your ordered pairs, and I'm going to make this bigger so that we can see this easier, you want to make sure you have an ordered pair that hits a perpendicular line. So right here, this one's not going to be a good ordered pair. Even though it's an ordered pair on that line, it's not the prettiest because you are in a half box. So what I recommend here is look where it hits at a nice, pretty ordered pair. So we have one right here, we have one right here, we have one right here, so on and so forth as we climb up this line. So all of these ordered pairs will work. It just depends on what you want to do. So what I personally would like to do, I want to make sure that I have, so that we know how to work both negatives and positives, I'm going to make sure that I have a little bit of both numbers. So I'm going to graph some negatives. I have 1, 2, 3, 4, 5 lines. I'm going to do this -4, comma, -7. So I'm going to show you how I get that. So let me write that down real quick, and I'm going to show you how I did get that. Let me change my color real quick so that we can see that how to do this. We see where this dot hits our x-axis here at -4, and we see where it hits our y-axis at -7. So when you're dealing with that, remember it is always x, comma, y. So I have -4, comma, -7. So that means my next ordered pair is going to be -2, comma, -6. The next ordered pair is going to be x is 0, y is -5. I have x equals 2, comma, -4 for my y, and then the last one I'm going to do is 4, comma, -3. So do remember, when we are dealing with this, your ordered pairs are really important for your process. So do note I transferred everything over to my table. Now I'm going to focus over here on this table to get my equation. So the big thing here is you want to make sure to transfer everything over to that table. So the first step we do is to find our coefficient. So remember, our coefficient is delta y over delta x. So it's our rate of change in our ordered pairs. So my first rate of change for delta y is +1 because we are getting closer to 0. So that's what results in it a positive 1. Here it is +2 for this x. Again, we are getting closer to 0. That means we're going to the right. So that means we have a positive line. You can also tell that from the graph. As x is increasing, so I'm going to show you over here, as our x values are increasing, our y values are increasing. So that means this is going to be a positive rate of change. So you can eliminate anything that has a negative coefficient. Alright, so coming back over here to our table to continue doing our delta y's, we have +1 for this delta y, +2 for this delta x, +1, +2, +1, and +2. So that means that our delta y over delta x is 1/2. Now please, 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 please do not flip this. Many students don't like fractions. We understand that. But a lot of kids want to switch this to 2/1. Do not do this. This is a fraction coefficient, and it is really, really important that you keep it in its fraction form. So this is 1/2, which is the same as 0.5. So you can use whichever. I recommend the fraction. So we plug that coefficient into our process table, and remember your coefficient always gets multiplied by your x value. So we have here, and I'm going to show this work down here so that we can see what's going on, or I'll just show it up here. Half of negative 4 is negative 2. I need to get to negative 7. So the big thing here is you need to figure out what extra can you put into this equation to get to negative 7. So I know negative 7, so if you need to, draw your number lines. That's why we did this at the very beginning of school. We start at negative 2, and I need to get to negative 7, which is over here. That means I go to the left. So that means that there's going to be subtraction. I went to the left. And I went to the left 1, 2, 3, 4, 5 to get there. So as of right now, with this first process column, I can see that I have to subtract 5 to get to my answer. So let's see if that works with everything else. So I'm going to zoom in on my table real quick again. I have 1/2 times negative 2. Half of negative 2 is negative 1. So we're going to show that up here again. Make sure that if you have to do this every time, you do this every time. So I have negative 1, and I need to get to negative 6, which is my corresponding y value. Again, if you need number lines, you do whatever you need to do. Again, I have to subtract, which is a minus, and I have to subtract 5 in order to get to negative 6. So here, again, it matches. So let's see if that works the whole way through. So I have 0 as my x value right here, so I'm going to do 1/2 times 0. I need to get to negative 5, so voila, works that way. 1/2 of positive 2 is 1. I need to get to negative 4, which is minus 5. 1/2 of positive 4 is 2. I need to subtract 5 to get to negative 3. So now that we've done our table, we now know what our equation is. Our equation is 1/2 of whatever our x value is minus 5 to get to our y value. And this is how you go from graph to table to equation. Again, your table is central. If you actually started with your equation, you'll plug everything into your table, do your process, then transfer it over here to your graph. If you started with this table right here, I recommend plugging in the graph first and then going down to the equation. So again, this is how you switch around everything. Again, table is the key to everything. You always want to get back to the table.